Once again, welcome to my class here, and here I am going to discuss a problem from the exercise 6.2 of your Ncert book of similarity of triangle. Here is an Ncert problem, question number 9. Okay, and it is an use of the concept of basic proportional theorem and converse basic proportional theorem. Okay, BPT and converse BPT concept we are using here. Okay, and in this statement it is given that a trapezium is given, and the trapezium diagonals of trapezium intersect at the point O. Here ABCD is a trapezium given. It is given ABCD is a trapezium. ABCD is a trapezium, and the diagonal AC and BD intersect at the point O, and we have to prove that AO upon BO is equal to CU upon DO. That you have to prove. Okay, let us do a construction for that, because this is a problem that we have to prove. The mathematical statement you have to prove. Okay, using the concept of the basic proportional theorem and converse BPT theorem. Okay, so that a construction is required for that. What is the construction you say? Through the point O, draw OM parallel to AB. Okay, so OM parallel to AB is done, which intersect AD at the point M. Yes or no? This is the construction, we have to prove it. Okay, understand? So this is the construction for the required statement, right? Okay, ON parallel to, you see, OM parallel to AB is done. OM parallel to AB is done. Okay, now proof. Look at here in the triangle DAB. In the triangle DAB, look at here. OM parallel to AB. OM parallel to AB. Once again you see, since OM parallel to OB, OM parallel to AB, yes or no? And AB also parallel to what, CD? So that implies OM also parallel to CD. Can you say also? OM also parallel to CD. Right? Okay. Now in the triangle, you see the triangle, in the triangle DAB, look at here. In triangle DAB, OM parallel to AB, in triangle DAB, okay, look at, let us remove this one, this point, we can clearly do. Now, see now, in triangle, okay, in triangle DAB, you see OM parallel to AB, so we can use the concept of the BPT, theorem of BPT, that what you can use now, AM upon DM must be equal to, in the triangle DAB, so BO is equal to DO. Yes or no? By BPT concept, look at here. Okay, in the triangle DAB, look at here, and OM parallel to AB, MO parallel to AB, so AM by DM is equal to BO upon DO. Okay, if a line run parallel to one side of triangle, it intersect other two sides in the same ratio. This is the BPT theorem. Okay, similarly, you see now, since OM parallel to AB, that's why OM also parallel to CD. Okay, similarly, in triangle ACD, Look at here, OM also parallel to CD. Why? Since AB parallel to CD. Since ABCD is trapezium and OM parallel to AB, that's why OM is also parallel to CD. So in the triangle ADC, look at here, OM parallel to what? AB. OM parallel to CD in the triangle ODC triangle. Look at here, triangle. You can draw a triangle for that. You will clear over that. Let us draw a triangle. Which triangle? A, D and C. Okay, understand? And this is the point O and this is the point M. You see OM parallel to CD. OM parallel to CD. Yes or no? OM parallel to CD. That's why AM upon DM. Similarly, according to BPT theorem, AM upon DM is equal to AO upon CO. This is also as per the BPT theorem. Right? Okay. Now equation 1 and equation 2. Equation 1 and equation 2. And you see AM by DM is equal to BO by DO. And equation 2 AM by DM is equal to AO by CO. Now you can compare the equation 1 and 2. And after comparing you can write that implies BO upon DO is equal to AO upon CO. Okay? Understand? BO upon DO is equal to AO upon CO. Okay? Now just you can transpose. Okay? Yes or no? Now you prove that AO upon BO is equal to CO upon DO. Understand? Okay? Now you can transpose AO taken to the left hand side. So BO upon AO is equal to DO taken to the right hand side. CO, DO by CO. So BO by AO is equal to DO by CO. Yes or no? Okay. Just you reciprocal it and you will get that. So BO upon AO must be equal to AO upon if BO upon AO is equal to AO upon BO and DO upon CO is equal to CO upon DO. So after reciprocal we can get, and let's see, and here we are getting the AO upon BO is equal to CO upon DO. Okay, this is what you have to prove it, and it is another simple problem for you. Okay, and here you can easily application and the use of the BPT theorem. Okay, using that we are going to prove. Okay, thank you all of you. Thank you. So let's see and watch it. Okay, and this exercise already practice it properly once again. Watch this exercise again and again. Okay, and also practice also again and again, and also practice the similar type of problem. Okay, with this, thank you. See you for the next class.